Hawaii, members from the Northern Lighthouse Board, Germany's Federal Waterways and Shipping Administration, the U.S. Coast Guard, L3 Communications USA, and Jotron Norway, partnered with satellite companies Orbcomm and ComDev to deploy AIS SARTs, AIS ePERVs, radar SARTs, a Class A AIS radio, and an ePERV with 121.5 megahertz homing. The tests were performed to detect and compare the data detected from surface, shore, air, and satellites. I can show you here a few of the devices in the water. If I can get this here to work. This is our dummy here we call Oscar. Oscar had an AIS SART attached to his shoulder there. And then over on this other photo, you can see the AIS SARTs out here on a floating device. There were two of those as well, and AIS ePERV. The test proved to be highly successful in detecting the devices by surface, shore, aircraft, and satellite by both Orbcomm and ComDev. The AIS devices significantly outperformed the 121.5 megahertz homer at much greater distances and have shown that AIS technologies could one day replace 121.5 entirely in ePERVs. I have those results available and would be more than happy to share those if anyone would like it electronically, or I have a few paper copies with me. I see I'm running out of time, right on time. Finally, I will leave you with the communication group's vision for the future of ENAV. I'll allow you to read it yourself. But getting there, it's going to take the spectrum and the coordination of all the ENAV working groups to come up with common interests and make this real. Thank you.
Thank you, Bill and Peter, for that double act. Our next speaker will be familiar to many of you. Jan-Hendrik Altman will be talking about the notion of the Universal Maritime Data Model. Jan-Hendrik is Deputy Head of Traffic Technology and Telematics Division of the German Federal Waterways and Shipping Administration. He holds a master's degree in electrical engineering from Darmstadt Technical University. He has a long history in AIS development, participating in the IALA AIS Committee and ITU Working Party 8B. He is the chair of the Architecture Technical Working Group in the E-Navigation Committee. Jan-Hendrik.
Thank you, Mr. Chairman, ladies and gentlemen. I'm also delivering this presentation on behalf of my group, the Architecture Technical Working Group, and it's also a little bit of breaking news. We had several intersession meetings since last September, since the last committee, and quite a bit of this material will be presented in nice writing to the ENAV 8 committee, and that may draw another 10 people to the committee, maybe. Well, the notion of the Universal Maritime Data Model. Overview of my presentation, I will give you a motivation rationale. I will talk about information not equal to data, and continue what Lee Alexander introduced earlier. I will talk about data modeling not equal to data encoding, develop the so-called IALA e-navigation stack, that's breaking news from our group, features of the IALA Universal Maritime Data Model, and of course some strategic considerations. When we do our work at our group, we closely consider IMO's documentation, and in particular NAF 54 Annex 12, which is a strategy, and I strongly recommend this document for your careful attention, because it explains in great precision what the scope and the goal of e-navigation is all about. And it's not vague, it's abstract, but it's precisely spelled out. Let's have a look at this in regard to the data. It says e-navigation is a harmonized collection, integration, exchange, presentation, and analysis of marine information. So what does mean harmonize? Harmonize means its orderly arrangement and structure is a prerequisite to do something harmonized with the data or the information. It repeats the thing and says this is the goal of e-navigation, to harmonize the information and the data and the system supporting this. And of course by electronic means. And OTREC, here's a machine and thereby engineers. So we have both users, operational people and engineers involved in the task, and that makes it interesting. Let's continue with this IMO document. There's a twofold motivation given in the IMO strategy. First of all, it includes already, and rightly so, the distinction between information and data. Namely, there must be both eventually, information structure and data structure. And it talks precisely about the humans needing information over here on the shipboard side and over here on the shore side. And then the document turns to the junction between these two. Such a data structure is eventually for the sharing of information amongst shore authorities. So here is now the data term introduced, and that's something for machines, namely IT. And machines more or less can understand data only. Engineers need a data structure in order to exchange data, and in order to achieve that nicely, they do something which they call data model. And of course, engineers love it, because it's so powerful once it's established. We continue with IMO. Now I borrow something from John Eric Hagen's group, and there is incorporated this table. By the way, it's already with a slight amendment in IALA20100325, but there was a little improvement made to this by the correspondence group. And what you see over here is a distinction between user information domain and data domain. And in between there's human-machine interface. So I took the liberty to expand this a little bit into a graphical image. And what you see over here is above the dotted lines, the human domain, the user domain. There's the information model, which is to be devised in accordance with user requirements and user needs. It contains information items and the properties. And you see this little arrow over here? That is how the information is portrayed, and that's exactly where Lee Alexander and myself are on the same page. It deals with the human-machine interface, and this human-machine interface, of course, is the operational presentation service to the data. Underneath now comes the machine domain, where we have a data model. And of course we need something which is called a presentation library. The data model for the machines contains data objects and properties, and it should be ontologically arranged, structured, and uniquely identified. So that's a goal. And I will use this concept throughout my presentation. Now, there is a precise definition, one precise definition. There are more than just one definitions, but there's one. What is the distinction between information and data? ISO defines information as knowledge within a certain context, and within that context it has a particular meaning. It defines data as a representation of facts, concepts, or instructions, which is suitable for communication, interpretation, or processing by humans or by automated means. So clearly you can recognize the distinction. So what is modeling? Modeling is to provide a structure to a plurality of entities. And obviously this conference has shown so far that we have a lot of entities to deal with. Well, and what is the benefit of the separation between information and data? Humans, users, really want information only. Machines are most efficient with data. We heard this many times throughout the conference. So we need to have the best model for both, the best model for the respective world. And that's the benefit by the separation. Let's take another look at what IMO has crafted, and that's an information model. As an example, for the VTS in this regard, we have a tree structure and the discriminator between the different branches of the task of users. And down here, we have almost the individual information items or the maritime information objects. So that's a model for the information domain. Again, back to this picture. Now I'm looking at the operation presentation surface, the human-machine interfaces. That is necessary to present data contained and processed within the machine, to present it to the human, to the user, without creating